Hello. I'm sorry I couldn't be live on the conference, so I will do this recording the presentation. So what I will present to you today is the combination of openEHR querying with SNOMED CT expressions. I am Pablo Pasos. I work at CaboLabs Health Informatics. I'm also part of different programs in the openEHR Foundation, and I do some training. I have online courses, and I work as a consultant. There, you have my information. If you want to contact me afterwards, if you have any questions, please do contact me. And on this presentation, I will show you a little bit of the EHR server. It's the implementation that I created of the openEHR standard, a little bit about the SNOMED CT expressions, just to have a little context. The use cases that this combination of openEHR querying and SNOMED CT expressions, where can this combination be applied, and which use cases that that combination can solve, can help to solve, and yeah, talking a little bit about the combination. I will do a little demo if I have time, and a little conclusion at the end. So the EHR server is the first open source clinical data repository that complies with the openEHR standard. So when I started when I released the first version of the EHR server, there weren't that was the only open source implementation of a clinical data repository. What the EHR server does, it is basically a generic clinical data store. It can store any kind of data structure and query those data structures that are defined by openEHR archetypes and templates. The implementation is, of course, compliant with the openEHR information model, and to add new structures to be stored and queried, there's no need to change the source code or recompile the application. It can all be done by configuration and using the administrative user interface of the EHR server. And also it provides high-level querying based on those archetypes and templates, the openEHR models. All the queries are defined also using a graphic user interface and can be executed via a REST API. It doesn't require to write any SQL or any kind of querying language to execute the queries, to create and execute the queries. And a little bit about the SNOMED expressions. If you know a little bit about SNOMED, it's like a big graph of linked concepts. Those links can be different kinds of relationships between concepts, and can be a generalization or specialization hierarchies. The relation there, the link is a something. So let's say something is a type of disease. Yeah, we'll see this later. And also these concepts have attributes, so we can link concepts with attributes and other concepts to represent clinical knowledge, and we can use that clinical knowledge to filter data, really, to represent content of data and to filter. And for filtering, we will use expressions, and expressions allow us to select part of the concept graph of SNOMED that SNOMED defines, and the expressions have a format that is an operator, a focal concept, and then we can add an optional refinement, and the refinement is just a list of attributes and values of those attributes. We will see an example of this. So if I want all the types of diabetes mellitus, and we have many types of diabetes, we just put the code of the concept ID for diabetes mellitus, and we use the operator on that operator means all descendants. Yeah, so this is the part of an operator working on a focal concept without the refinement. And the second example there, we have a focal concept that is the infection of the respiratory tract, and also the minus means we want any type of infection, but we have a refinement there that is a relationship really. We have the causative agent equals virus. So we need this expression is really filtering all the respiratory tract infections by its cause, and that should be virus. So we can use that expression, that this power to filter data on a clinical database. We will see how this works later. So the use cases, very quick. We can use querying with the help of filtering by SNOMED expressions. For clinical decision support, we can implement complex rules to launch alerts, reminders, or recommendations to clinicians when they are using an EMR, for example, or a mobile application. And those complex rules can be based on some health problems like diabetes, like the expression that I showed you, that we can get all the types of diabetes. I will show you how that works, or certain conditions like the patient is obese, patient status. We can select, for example, patients that are older than 50 years old and are male. That is only using the openEHR querying mechanism, not SNOMED directly, but the combination of both allow us to, for example, filter by health problem or filter by certain medication or type of medication, because SNOMED also contains drugs, so we can use that in openEHR queries. Yeah, and we can select patients based on combinations of these conditions. The patient that match those conditions might have certain combination of risk factors, maybe, and we can show an alert on the system to a clinician, and the clinician can, I don't know, maybe order an exam or check the patient. I don't know. The system can assist, but the decision is on the clinician or what to do with that alert. Also, we can use this for patient selection for clinical trials. If we want to test a drug or a certain population with certain age, sex, and certain conditions, maybe a certain type of cancer, we can also use SNOMED expressions to filter by certain health problems, certain types of cancers, or maybe also by the medication they are taking for the cancer, etc. And we can constrain the group of people that we can invite to participate in our clinical trial. And that is a very useful use case, because sometimes that is done manually, reviewing paper records. Another that is similar use case is the patient selection for healthcare plans. Let's say your hospital has a weight control plan, and you want to select from all your patients the patients that have overweight or are obese or have severe obesity, and maybe you want to focus on female patients that are, I don't know, maybe younger than 40, maybe older than 60, I don't know. that can be done combining openEHR queries and also SNOMED expressions. And of course, we can get data out filtered by certain criteria for data analysis, reporting, research, population health, etc. So the use case list is huge for this kind of technology and this kind of querying mechanisms. So what we are going to do is we are going to create openEHR queries that are based on an information model and a specific data structure, and we will use SNOMED CT expressions to filter data, really, as data filters. So we can create really complex queries in a simple way, in a very simple way. So if because the full demo of the querying mechanism takes like 15 minutes or 20 minutes, that is all the time that I have for this presentation. I have made a video for you if you want to watch the full presentation, the full demo here, but I will show you here. Let me go back to the virtual machine. Just how to create, this is the user interface of the HR server, how to create very quickly a query from the query builder, the HR server query builder, using a SNOMED expression as filter. So I want to create a query that follows what I already showed you about the respiratory infections that are caused by a virus. So what I will do is I will select, first I input the name of the query. The queries are defined on the user interface. Then I select that the result of the query, I want clinical documents in openEHR. Those clinical documents are called compositions. I will select just to group this query, the demo queries, and I will select the clinical document structure that is defined by an openEHR template. I will select this one that is an encounter that has just a record of diagnosis inside. I will select the specific archetype that models the structure of the diagnosis. And here I can see all the data points in the diagnosis archetype. And I can select the one that is a code text, that is where we will store the diagnosis, the specific codes for the diagnosis. And we can see here that we can define a criteria. First, the terminology ID will be SNOMED CT, that is defined on the archetype itself. We can make the code equals to certain SNOMED CT code, or we can make a matcher for a list of codes. So I want the diagnosis that is on this list of these 3 SNOMED CT codes. These are fake codes, of course, but I wanted to show you this operator. This is the new operator, the in SNOMED expression. Here I will paste an expression, the same expression that I showed you on the presentation. So is the respiratory tract infection is this code. I want any type of respiratory tract infection, and this will be caused by virus. So I will first validate this expression is correct. So green is correct, and the service that validates this expression is provided by Betatech. I'm working with them. We are partners. And the terminology will be SNOMED CT, that is set by the template, and I will add this criteria to the query. So I have the archetype of diagnosis, the path that references the specific point where the diagnosis is registered on the clinical documents that comply with the template that I selected, all these openEHR archetypes and templates. This data point is of type code text, and this is my condition. I want the code to be in this SNOMED expression, and this is the SNOMED expression for the respiratory infection caused by virus. I can select here some parameters. I can select, for example, the output format, and I can test this before creating. Here I can select one EHR. If I don't select an EHR, the query will be executed on all the EHRs. And I can also select if I want the full clinical documents that contain the diagnosis equals any type of respiratory infection caused by virus, or just a reference to it. So I will just return the reference. That is quicker, of course. And I execute, and now we have results. The result is very easy. It's a JSON structure on this case. This is the ID of the EHR containing the clinical document that has a record of the diagnosis being any type of respiratory tract infection caused by virus. And this is the specific reference to the clinical document. It's not the full clinical document. Here we have the ID of the clinical document. Using the REST API, we can get the full content of the document just by its ID. So here I will create this query. And when I create the query, it will be available to be executed from the REST API. Yeah. If I go back to the query list, I can also do something very useful, that is executing a counter here, and that is a quick indicator that will be tested against all the EHRs in the database that I can access. And this is telling me that the 73 EHRs have at least one clinical document that contains a diagnosis that is respiratory tract infection caused by virus. So this is a very quick indicator. Yeah, we can check a population using this very quick indicator, and that's it. We can create in minutes openEHR queries that can filter data by using SNOMED expressions. So again, if you want to watch the full demo with more queries and combinations of queries, just watch that video. As a conclusion, very quick, what openEHR does is it enables to store and query any kind of clinical data structure, because all the structures and constraints are defined by external models. Those are archetypes and templates. And since the implementation in the EHR server is based on those archetypes and templates, the querying, how we create queries, doesn't depend on a specific database brand. So the queries are really using just the models. We select the template, we select the archetype, we select the data point, and we create some criteria there, some filters there, and that's it. Internally, there is an engine that transforms that query, high-level query, into a SQL query for MySQL. That is the database that I'm using. But the query itself is not depending on a specific database technology. On the other hand, the SNOMED CT has a lot of clinical knowledge in it, and we can use expressions as a mechanism to filter that knowledge and apply those filters on specific scenarios. We apply those filters, in this case, on queries. Yeah, when the query engine detects that inside the query criteria there is a SNOMED expression, it evaluates the SNOMED expression against a service provided by Beratech. I already mentioned that. And from their service, what we get is a plain list of codes. And that is injected into the SQL query. It is generated by the engine. Yeah, it takes the high-level query, it evaluates all the referenced SNOMED expressions, and then generates just plain SQL code. Yeah, and the combination is really powerful. It really allows to create very complex queries very easily. I create one query that is very difficult to create from scratch on a simple EHR. And that is simple because we implemented 2 standards that are well defined, and we have a tool that implement the standards, and we have services that allow us to evaluate the SNOMED CT expressions. So that is very, very useful, and our focus is always on using standards as much as we can, so we don't end up with custom and proprietary solutions. Yeah, and this is all open source, so you can use this or you can learn from it to create your own tools. Yeah, and the implementation of these use cases that I mentioned before can be really fast using these 2 mechanisms together, using openEHR querying mechanism and the SNOMED expressions inside the openEHR queries. So it can help a lot to implement complex scenarios. And these are just some references about the EHR server, Veratech tools, SNOMED tools, the tool that I use to load data into the EHR server. And you can see the demo also on how to load data into the EHR server if we want to test this this demo yourself. Yeah, you can do that. And this is my information. Thanks for your attention. If you have any questions, please send them through email. I'm sorry that I can't be there live, but I hope everything goes well on the conference, and I will try to see the presentations afterwards of other colleagues. And I'm sure the conference will be great, and everyone will learn a lot from it. And this is my little grain of sand from the conference, from me, from CaboLabs. Hope you enjoy this, and hope this helps you in your projects in the future. Bye-bye.